Once again, did we have to do much work besides maybe drawing a picture here?
No.
Did
No.
we? No.
Okay. So the third way is if we have two fractions, they have different numerators, 15 and 5. They have different denominators, 18 and 6.
Is anything the same there?
No.
No.
So we have to do some work. We have to get that pencil going, and we have to do something mathematical or math. Can I do anything to this 6 to turn it into an 18?
Yeah.
What? Yeah, what do I do? Times, because we're getting bigger. I like how Madison has out her number chart.
Yeah.
That's going to help her, for sure. She has her toolbox ready to go, Madison.
3.
Okay. Now, so I'm going to keep this as 15/18ths, but I'm going to switch this 5/6 to 18ths. And we just said we had to multiply it by 3, right?
Yes.
Because 6 times 3 is 18. Well, Martin Luther King tells us, whatever you do to the top, you must do to the bottom. Or whatever you do to the bottom, you must do to the top. So we're going to use our 5, and we have to multiply it by 3, right?
Yep.
What's 5 times 3?
15.
Whoa! Whoa!
Yeah, it's an equal.
So what you're telling me, Mr. Adamson, is that 15/18ths and 5/6 are equivalent or equal
Equivalent.
fractions? I think I saw one equal sign on that problem, and that's okay. That's why we're practicing.
But do you guys see how much work this took? They didn't. Mr. Adamson just didn't go up. Yep. Like to this one when he didn't have. Yep. Equal. Like he, or this one's greater.
Yeah. Oh, that one's got 15. The other one's got 5. It's
of
gotta be
course,
bigger.
duh. And remember our other way to do this. If you're not sure and this way confuses you, remember 6, 18. Take the bottom numbers. The bottom numbers here. 6. Count. Skip count by 6. 6, 12, 18, 24. All right. Then this one. 18.
Please,
Wow.
don't go any further.
That's scary.
18 is your common denominator.
How many times did we skip count to get to this? 1, 2, 3. So multiply by 3. How many times for this?
1.
Times 1.
So this one's not going to change.
Which we know anything times 1 stays itself.
And this one we're going to multiply by 3, which, looky, lemon cookie. You did it. Or we did it. I did it. Okay? There's a reason why I only gave you 6 problems of homework last night. It's because I knew that they were not going to be 6 problems that you, or they weren't going to be problems that you could look at and go, greater than, less than, greater than, equal to, less than, greater than, equal.
If that was the assignment, Mr. Adamson would have given you about 4 pages of that.
Okay? So keep that in mind. If you were able to do that homework in like 2 minutes last night, ooh, maybe that's a red flag that maybe I didn't do it quite right. So, I like the idea of the moral of the story. So what's the moral of the story? If you don't have like numerators or like denominators, get to work. Right? That's really what we're talking about here. Okay? Now, on page 11, it says special cases. Because we all know in math, sometimes there's special situations. You can always compare 2 fractions by rewriting them so they have the same denominator. We did that, didn't we? We did that. That's exactly what we just did with the 5/6 and the 15/18ths. By rewriting them so they have the same denominator. However, in some special cases, you can compare the fractions more efficiently just by using reasoning. Let's put that into easy 5th grade to understand words. Sometimes you don't have to do the work. Sometimes you can figure it out by looking. You can save yourself time and just look at them. So here's an example. Let's say that both fractions are close to a half. Okay, I'm gonna need 100 and 27% on this one. So this might be a little bit confusing to some of us. So, eyeballs up here. If there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, I want 40 eyes, because everyone has 2 eyes in here, right?
I hope so.
Okay, good. So I want 40 eyeballs looking up here. That's why I wore the flashy shorts today, so everyone would look up here at my fancy shorts. Anyway, both these fractions are close to a half. Because if we were talking about eighths, if eighth was our denominator, what would we have to have on top to make it half? What is half of 8? If I had 8 and I cut it in half, what would I have? Abby? 4. Okay. So, Kendra, why don't you, whatever you need to talk about, get it out, please. So I'm going to try, the more focused we are, the quicker I'm going to be. Okay, and I think it'll actually work out better. So, if we said 4/8 was half, and we have 5/8, do we have more than a half, less than a half, or exactly a half? If 4/8 is our half number, but we have 5/8, does that mean we have more than half, or less than half, or equal to a half? Well, I can tell you right now, it's not equal to a half, because the 4 is not a 4. This isn't a 4. So do we have more than a half if we have 5/8, or do we have less than a half?
Less.
Well, hold on, you guys.
Think about this, guys.
Visualize.
Slow down.
Yeah. Sometimes when we slow down, we actually work faster.
And think about it. Oh, like denominators, even if you want to compare these two. Like denominators, we know this is half. What's bigger?
Avery, do we have more than a half or less than a half if we have 5/8? Awesome!
Bingo, Avery. Bingo.
I love it. By the way, even if she was wrong, I would have loved that
Yes.
she tried. Sometimes you just have to take that first step. And then you'll be amazed. Brianna figured that out. First couple days, Brianna didn't want to take that first step, and now she's like sprinting through math class. I'm serious.
We love it.
Yeah. All right. What's half of 5? If we want to figure out what half, we want to figure out what that half number is. Be careful, it's an odd number, so it's going to get ugly. It might get a little ugly. If I had $5 and I wanted to give half of it to Mr. Lencher and keep half for myself, we'd each have 2 and half. 2.5, 2 and a half.
And think about it too. Like if I have half a dollar in my pocket, I have 50 cents.
Right.
So that's what this 5 means. And think of it like that's what it means with half. I know it's kind of confusing, but that's what it means.
But the thing is, you don't even have to freak out too much. If 2 and a half is our, or $2.50 is our half number, we have 2. Okay, is that more than, is this more than this, or is this less than this? Less. So guess what? We have fractions that have different numerators, different denominators, but by just looking and going, well, that's more than a half, that's less than a half, that means which one's going to be greater? If half is kind of our benchmark, and 2/5 was less than a half, and 5/8 was greater than a half, which one's going to be bigger? They're both close. They're both really close to a half, but which one's bigger because of what we figured out up here? Michaela? Five-eighths. 5/8. So 5/8 would be greater than 2/5 because 5/8 is bigger than a half. 2/5 is smaller than a half. Case 2, it says both fractions are close to 1. Both the fractions are close to 1. So it says the strategy is compare both fractions to 1. The fraction closer to 1 is greater. And they gave us the example 1/6 and 1/7. And they used a number line. Now, here's kind of where I have I don't know if this is a great strategy, because most of you don't carry around perfect number lines in your pockets, do you? Most of you don't go, oh, hold on, let me get out my 1/3 number line and my 1/4 number line, and I'll see, and we can see which one's closer, or whatever. So, on a problem like this, I'm actually going, well, actually, that wouldn't matter.
And it is hard to draw too. Like if you're like,
I'm sorry,
if
5, 6, and 6/7.
it's hard to draw too when you're doing this. Like, oh, I don't have a number line, so maybe let me try and draw
Right.
it. You can't. It's hard to figure out the fractions.
I can make them both the same length. That's fairly easy. This is 0, this is 0, this is 1 whole, this is 1 whole. And oh, I have to divide this into 6. 1, 2, 3, 4, 5, 6.
See, and this is freehand, so Mr. Adamson could be totally off on his spacing. It may look good to his eyeball, but it's not like a perfect line like we can do on a computer, is it?
Right. And it's clear to say this is my 7th. That 7th
Yeah.
is a lot bigger than like
Yeah, totally.
this 7.
And I think a lot of mistakes are going to get made.
So, let's think of some other ways that we could tackle a problem like this. Here we go. I want you to imagine that you're running a race. So, tie up your sneakers, nice and tight, make sure they're knotted well so you don't trip and fall. And I'm going to go across, I don't imagine my race is across our classroom. And in the first race, I'm going to do it in 6 steps. 1, 2, 3, 4, 5, 6.
Oh.
And then on the way back, I'm going to do it in 7 steps. 1, 2, 3, 4, 5, 6, 7. So we kind of have to think to ourselves. In this one, I'm 1/6. Oh, maybe that's a fun way to do it too. I'm 1/6 away from a hole. I'm 1/7 away from a hole. Which one am I closer to a hole then? This is going to be wacky. And if you don't get it, I understand. This is going to be the first time, hopefully not of many, but this is going to be the first time that I say, if you don't understand exactly what I'm saying, it's okay.
So we've learned other strategies.
We do know, we'll talk about it another way. But here you're 1/6 away, here you're 1/7 away. Which one are you closer to 1 hole with? Adriana, what would you say? 1/7. Okay.
Well, and think about it, guys. You can just line up these two fractions, since we know that this is 1/6 away and 1/7 away. Just look at these two fractions. What one's bigger?
1/6 is bigger, right?
Yeah.
Because we have like numerators, don't we?
Yeah.
So we know how to do that one.
So with this one, you're missing a bigger chunk compared to this one. You're missing a smaller chunk. Okay. If that made absolutely no sense to you, that's okay. We're going to talk about another way that we're going to actually do this just mathematically. Because the other ways, I'm sorry, they involve more mental math. And And mental math only works if you're like, yeah, this makes sense. If it doesn't make sense, mental math is terrible. So let's just take those two fractions again. 5/6, 6/7, and we're going to use Mr. Lencher's skip counting. So if you're not familiar with your counting by your sixes or not familiar counting by your sevens, please, please, please do me a favor. Get out either your multiplication chart, get out your numbers in your notebook, get out something so that way you can see what the number pattern is when we skip count. Paige has hers out. Awesome job. Got to your notebook. Really? Why? Why are we writing about this though when it's math class? Either that one or that one, I would say. Okay, here we go. Let's count by our sixes. 6,
12, 18, 24, 30, 36, 42, 48.
freeze. Freeze. Is that hard?
No.
Does it take work? Yeah,
Yeah.
absolutely it does.
And also, guys, if you're thinking, man, I can't go 6, 12, 18, that gets confusing, 6, then add 6 more. 6, 7, 8, 9, 10, 11, 12. Oh,
Or
add
use
6
or
more.
use the tools in your
Yeah,
toolbox.
exactly.
Okay?
It's right on your multiplication table there.
Okay. Let's do our sevens now. Let's count by our sevens.
7, 14, 21, 28, 35,
42, 49, 56.
Freeze. Was that hard?
No.
Did it take work?
Yes.
Okay. Now, you're going to play a game called What Do They Have in Common? See a 6, don't see a 6. See a 12, don't see a 12. See an 18, don't see an 18. 24, nope. 30, 36, 42.
Yes.
Bingo. Winner, winner, chicken dinner.
So 42 just became your common denominator. Now, what are we going to do to figure out what's an easy way to figure out what did you do to this 6 to make it 42? What could you do to figure out? Yeah.
You can time 6, 7.
Okay. Well, you can figure out how many times it was. You're right. And it was 1, 2, 3, 4, 5, 6, 7.
How many hops did we take?
7. So this is going to be our times 7 up here. 6 times 7 was 42. 5 times 7 is?
5.
5, 10, 15, 20, 25, 30, 35. Good. What can we do to figure out what we did to the 7 to make it 42? Obviously there's some multiplication involved. What if you don't know your math facts? What if you don't know 6 times 6 is 36? Or 7 times 6 is 42? What can you do? You've already done the work. Use it. Here's my example. Could you imagine? How long do you think I'd want to do this job? If Mr. Ebert said, Mr. Adamson, you're going to go into that ball field out there, and from 7:30 till 4 o'clock every day, you're going to dig holes. And then, so I would dig holes today, and I'd come back tomorrow and say, all right, Mr. Ebert, what do you want me to do? And he said, I want you to fill in those holes. And there was no work done in those holes. It's not like he was planting trees or doing anything. All he was having me doing was digging holes one day and filling them in the next. Would that be a good use of my work?
No.
So here's my question. If you're going to take the time to do these, use them. If I'm going to dig the hole, I should do something with the hole. If you're going to take the time to write out your skip counting numbers, use them. 1, 2.
3, 4, 5, 6.
And there's no shame in that, guys. I actually think it's the people who are better math students are people who show your work and not try and do it all in their head.
This isn't timed. It's not a race. The winner is the person that gets the right answer, whether they get it in 1 minute, 1 second, or 15 minutes.
People don't know.
It's okay. Yes, Angel.
It says 36 instead of 35.
I'd like to say I was just testing you, but I made a mistake. Nice catch. What about here? 6 and 6 is?
36.
Okay. So now we have our equivalent, or our fractions with the common denominator. Which is bigger, 35 40 seconds or 36 40 seconds? Go ahead, say it.
36.
36 is bigger than 35? So therefore, 5 6 is less than 6 7ths. By the way, you can do this, you can do that same job with every single problem. Well, are there shorter ways to do it? Absolutely. But is this kind of like the guaranteed way? I think so.
And guys, just notice too, how much work? Do we have any like numerators or denominators? Nothing. That's your key. That's the first thing you need to look for in these problems. Okay, if there are, like the tops are the same, then you can go for it. Do what you do. But I see nothing the same. Nope, that's not the same. Nope, nope, nope. Then I say, okay, it's showtime. Time to get down to work. Okay, now time to get writing. Because this needs a lot more work. Because I know personally, for me in my math, I can't just look at that and say, yep, I got it. Honestly, I couldn't tell you with full certainty.
And even if he was confident but not positive,
Yeah.
and I'm maybe not even as smart as Mr. Lencher is in math, but if I take the time and I guarantee my answer, I'm always going to be right. He's going to be right most of the time, but I'm always going to be right. And you know what? I'd rather be always right and just take a little bit longer time. And to prove that, our good friend Penguin here is going to solve a problem, and we're going to time it. And I'm gonna literally, obviously I'm the hands of the Penguin here, but I'm gonna pretend that his brain, he's been in this class just like you have. His brain has all the knowledge that your brains have, because you're all great listeners. So I'm gonna pull it up, a timer, and I'm gonna show you what I mean. Toot, toot, toot. Clock. So when I say go, Paige, I want you to hit start. Okay? I need 2 fractions to start. So, Mr. Lencher, can you give me 2 fractions?
Yes.
Please? Do not have common denominators.
3 7ths.
Okay?
And 4 9ths.
Okay? All right. Mind if the Penguin uses your number chart? Awesome.
Using resources. Good job, Mr. Penguin.
On your marks. Get set. Start. All right, here we go. We don't have common numerators. We don't have common denominators. I have to get to work. Here we go. I'm going to write down my skip counting numbers of 7. I don't know them, but I'm going to look in my chart here. Here they are, here they are, here they are. There's 7, 14. I'm copying them right down from my book. 28, 35, 42, 49. Oh, that's probably far enough. I'll do 9 next. 9, because here's that one. 9, 9. Oh gosh, there it is. 18, 27, 36. All I'm doing is copying down right from my number. 54, 63, that's probably good. 9, no 9. 18, no 18. 27, no 27. 36, no 36. 45, no 45. 54, no 50. Oh, no. Oh, you know what? I'm going to go back to my 7s because I noticed that my 9s are getting big, but my 7s kind of stop. So after 49 is 56. Oh, that's not a match. After 56 comes, oh goodness, 63. Ha! Ha! There they are. They're both 63. So my new denominator is going to be 63, 63. And to do 7, I used 1, 2, 3, 4, 5, 6, 7, 8, 9. I used 9 sevens, and I used 1, 2, 3, 4, 5, 6, 7 9s. Now I have to multiply these by, oh gosh, 9 times 3. Oh, I already have it right here. 9. 1, 2, 3. It's 27. And 7. Oh, I have 7 up here too. 4 7s. 1, 2, 3, 4. 28. Oh, they're common denominators. 27, 63. 28 is bigger than 27, so therefore 3 7ths is bigger than 4 9ths. Stop. How long?
2 minutes and 44 seconds.
2 minutes and 44 seconds. Almost 3 minutes. I get it. Wow, that took a long time, Mr. Penguin. But because this nice teacher, Mr. Lencher, only gave him 6 problems, that means it only took him 18 minutes to do his math homework last night. Which isn't that long at all,
No.
if you think about it. 18 minutes is not a lot of math homework in a night. So,
And wouldn't you rather be sure about it? Like, Mr. Penguin can walk away knowing that he did everything he can. Yeah, you may do a lot of work and you may make a mistake, and that's fine. But wouldn't you rather like to make a mistake when you knew you tried your best instead of just guessing?
Yeah.
Exactly. I would like to say, you know what? I tried my best. I maybe made a little mistake. I did, but that's okay. I corrected it on the next one, and now I learned from it.
if you don't believe this yet, I want you to. Every day when I was 20 years old, I shouldn't say every day, every Tuesday and Thursday when I was 20 years old, first semester of college in the fall, I would go into Dr. Bohr's class. And every single day he'd wear a button that said that. Hard work done well feels good. What does that mean? If you do your work and it's a challenge, but you do it well, you should feel good about yourself. You should have pride, right? You should go, yeah, I did this. I can do this. I'm great at this. So, what we're going to do is I'm going to stop for now, and we're going to have a nice chunk of work time